Hey everyone, welcome to another deep dive into the world of personalized medicine. We're going to be talking about a drug called Siltuximab.
Yeah, this is a really cool example of how we are getting better and better at understanding all the little details of how our bodies work, especially when it comes to stuff like the immune system. And siltuximab, it's really all about precision. It's like zeroing in on this one specific target called interleukin 6, or as the scientists call it, IL-6.
So for today's deep dive, we're using this recent article. It's from a company called Assay Genie.
Oh yeah, I've heard of them.
They're a company that provides biosimilars for research.
So kind of like making sure that scientists can actually use these complex drugs.
Exactly.
Hmm?
And the author of this article is Marina Alberto, PhD. So we know we're working with some solid info here. Now, for anyone who's new to this whole world of immunology, you might be wondering what is so special about this IL-6.
Oh yeah, IL-6 is it's kind of tricky because it can be both good and bad for you. You know what I mean?
Yeah, sort of like a double-edged sword. Exactly. So it's a protein, and it's really important for regulating your immune response, which means it's really essential for, fighting off infections and just keeping you healthy overall. But here's the thing. Too much IL-6 can actually make inflammation worse, and that can lead to a bunch of different diseases.
It's like that Goldilocks thing, right?
Yeah.
Not too little. We need just the right amount of IL-6.
Exactly.
And so is that where siltuximab comes in? It's like a guided missile that specifically targets and stops all that excess IL-6?
Exactly. Okay, so imagine for a second that IL-6 is a key,
Okay,
and the lock is its receptor on a cell.
got it.
So when that key goes into the lock, it triggers this whole cascade of signals that cut off inflammation.
Oh, okay.
But what siltuximab does is it acts like a plug blocking the keyhole.
Yeah.
So that way IL-6 can't even attach in the first place.
Oh, I see. So it's stopping that whole chain reaction before it can even begin.
Right,
That's
sure.
amazing. But what does that mean for actual patients? Are there real-world applications for this kind of targeted approach?
Oh yeah, absolutely. In fact, siltuximab, it's already FDA approved for treating this rare disease. It's called idiopathic multicentric Castleman's disease.
Hmm.
We usually call it iMCD for short. And actually get this, it's the very first and only approved treatment for iMCD.
Wow. So this is a total game changer for people with this disease. But just to back up for a second, what exactly is IMCD? I'm not sure I've ever even heard of it.
It's this really complex disorder that causes lymph nodes to grow abnormally all over the body.
Okay.
And those enlarged lymph nodes, they cause a whole bunch of symptoms, like fever, fatigue, anemia, even organ enlargement in some
That
cases.
sounds really serious. And so this is all driven by too much IL-6.
Yeah, you got it. IL-6 is like the mastermind behind all of that, the uncontrolled inflammation and the overgrowth of lymph nodes. So before siltuximab came along, patients with IMCD, they really didn't have many options, and a lot of times the prognosis wasn't good. But now with this targeted therapy, we can actually get the disease under control. And that means we can really improve patients' lives.
That's incredible. So siltuximab is literally giving hope to people who might not have had very much before. But I understand this is just the tip of the iceberg, right? There's even more potential for siltuximab beyond IMCD.
Oh yeah, definitely. Think about it. Since IL-6 is a key player in so many inflammatory processes blocking it, it could have a huge impact on a lot of different diseases. And researchers are already looking into that.
Now you've got me really intrigued. What other diseases are on their radar?
One of the big areas is cancer. Specifically, we're talking about this type of blood cancer called multiple myeloma. IL-6, it can actually fuel the growth of the cancer cells. So using siltuximab to block IL-6 could be a potential way to treat it.
So it's not just about treating IMCD, it's about targeting that underlying inflammation in a bunch of different contexts. That is so fascinating.
And it goes beyond just going after the cancer cells directly, too. There's this other thing called cancer cachexia that researchers are looking at using siltuximab for.
Okay, I might need a little refresher here. What exactly is cancer cachexia again?
It's basically this really severe wasting syndrome that affects tons of cancer patients. It causes people to lose a lot of weight, muscle mass, and just overall strength. And it's not just about how it looks either. It really impacts patients' quality of life. It makes it harder for them to handle their treatments.
Oh, I see. So it's way more serious than just losing a few pounds.
Yeah, exactly.
It can make everything so much harder for people who are already going through so much.
And you want to know the crazy thing?
Yeah.
IL-6, it's involved in this too. It actually contributes to the inflammation and the breakdown of muscle and fat tissue. So researchers are hoping that by using siltuximab to block IL-6, we might be able to at least slow down this whole process, maybe even reverse it in some cases.
Whoa. So this one drug, just by targeting this one single molecule, could potentially impact all these different conditions. That's really remarkable. It says a lot about the power of this whole targeted therapy approach.
Right, like we're finally able to get to the root of the problem instead of just dealing with all the symptoms afterwards.
This is definitely changing the way we think about medicine. But now I'm curious, what does this mean for the average person? Why should someone care about Siltuximab if they don't have iMCD or cancer?
That's a great question. And it's something we're going to talk more about after a short. Well, actually, we're just going to keep going. We'll get to the broader implications of all this groundbreaking research and what it could mean for the future of medicine right now.
This sounds good to me.
Yeah, so we were just talking about how Siltuximab could make a real difference for people who are dealing with cancer cachexia.
It's hard to imagine how much better their lives would be if we could slow down that wasting process or even reverse it. Think about it, more energy to actually enjoy life, you know?
Exactly. And being able to handle those tough cancer treatments better, too.
Yeah, it could really improve their quality of life.
And that's what makes all this research so exciting. It's not just about helping people live longer, but making sure those extra years are actually good years.
Absolutely. Because fighting cancer isn't just about attacking the tumor, you know? It's about supporting the whole person.
For sure. And that's where these targeted therapies are so important. We're not just blasting the body with all these harsh treatments anymore. We're getting way more specific. We can zero in on certain molecules like IL-6 that are causing all the problems.
It's like we're finally learning how to speak the body's language, figuring out those complicated molecular pathways, and then developing treatments that can intervene with incredible precision.
Exactly. And remember how we talked about IL-6 being involved in so many different things in the body?
Yeah.
Well, that means Siltuximab and other drugs, they could potentially treat a whole bunch of inflammatory conditions.
Okay, now I have to ask, what other possibilities are scientists looking into with this targeted approach?
Well, one big area is autoimmune diseases.
Oh, right. Where the immune system is attacking the body's own tissues.
Exactly. So you've got conditions like rheumatoid arthritis, Crohn's disease, lupus. All of those involve chronic inflammation.
And I bet IL-6 is involved in a lot of those too, huh?
Bingo. So researchers are really interested in seeing if drugs that block IL-6 like Siltuximab could help manage these conditions.
So it really is like a master key that unlocks a whole new way of treating some of these really tough diseases.
Yeah, and the research is moving so fast, we're learning more every day about how molecules like IL-6 work in the body, both when we're healthy and when we're sick.
That's so cool.
And all that knowledge is leading to even more targeted and effective treatments.
It's amazing to think that we live in a time when science is moving so quickly. There are so many possibilities for the future of medicine. It's mind-blowing.
It really is. It's a great time to be alive, especially if you're into science and medicine. We're seeing this huge shift toward more personalized and precise treatments that are tailored to each individual patient.
It really makes you wonder what the next 10 years will bring in terms of medical breakthroughs. Like, could we see targeted therapies for Alzheimer's, Parkinson's?
It's hard to say for sure, but the possibilities are really exciting.
Right, like will we be able to cure autoimmune diseases?
Right.
Or even prevent them altogether?
That's what I find so inspiring about working in this field. There's so much hope and optimism that we're on the right track. Like we're finally starting to figure out how to tackle some of these really complex diseases.
And I think this deep dive into Siltuximab is a perfect example of that. It shows the power of scientific curiosity and how important research is, and just the amazing potential of human ingenuity to solve some of the toughest problems we face.
It all starts with asking questions, being curious about how things work, wanting to understand the world better. Don't ever lose that sense of wonder and curiosity. That's what drives all this progress and leads to new discoveries.
I couldn't agree more. Now, before we wrap up this deep dive, I want to turn it over to you, our listener. We've covered a lot today, from the ins and outs of IL-6 and inflammation to how Siltuximab could potentially treat all these different diseases. What are your thoughts on all of this?
What surprised you? What questions do you still have? We'd love to hear from you. And then we'll be right back with a few final thoughts on this incredible journey into the world of targeted therapies.
All right, we're back and ready to wrap up our deep dive into Siltuximab and the future of targeted therapies.
It really is amazing how much we're learning about IL-6 and its role in so many different diseases.
You know, earlier we were talking about Siltuximab being like a master key unlocking all these new ways to treat different conditions. But it also makes me think of another analogy.
I'm curious.
It's like, for so long we've been trying to fight disease with a sledgehammer, just
Yeah.
hitting it with these broad treatments that have all these side
Yeah.
effects. But now with targeted therapies like Siltuximab, it's like we finally have a scalpel. We can be so much more precise,
I like that.
zero in on the problem without causing so much damage to the rest of the body.
It really is a huge change in how we think about medicine. Moving away from those one-size-fits-all treatments and toward therapies that are truly tailored to each patient.
It's personalized medicine in action. It's not just about the science, but about recognizing that every person's body is different, and their treatment should be different too.
Exactly. And as we learn more about genetics and those molecular pathways, we're going to see even more of these personalized treatments. It's a really exciting time to be in medicine.
It is, but of course, all this progress brings new challenges.
Oh yeah, definitely.
Like we talked about cetuximab's potential to treat so many diseases from cancer to autoimmune conditions, but these cutting-edge treatments, they're often really expensive, right?
IR. Developing and manufacturing these drugs, it costs a lot. And that can make it hard for some patients to get the treatments they need.
Right. So while we're celebrating all these amazing scientific advances, we also need to be talking about how to make these treatments accessible to everyone.
Absolutely. It's about making sure that everyone benefits from these breakthroughs, not just the people who can afford it. This is a challenge we all need to work on together.
So as we wrap up this deep dive, I want to leave our listeners with a few key takeaways. First, targeted therapies like Siltuximab are really changing the game when it comes to treating diseases. They're precise, they're effective, and they offer so much hope for people with a whole range of conditions.
And the future of medicine is looking really bright. We're moving into this incredible new era of personalized medicine, and it's going to revolutionize healthcare.
But we have to remember that science is a journey. There are going to be bumps along the way. But by being curious, working together, and making sure everyone has access to these new treatments, we can use these amazing discoveries to benefit everyone.
Couldn't have said it better myself. Thanks for joining us on this deep dive into Siltuximab and the future of targeted therapies.
And thank you to our listeners. We'll be back soon with another deep dive into a fascinating topic that's shaping the world around us. Until then, stay curious.